right, welcome back. This is video 3 of section 7.2, not counting the bonus video 7.1b, or video 1b. Guys, I want to talk about substitution, and the whole point here is what do we do if a function is too complicated and we don't just know the antiderivative? So let's just dive into an example. I've got a function, and the function is sine of x times e to the cosine of x. And you might ask yourself, why do I have this function? It's irrelevant. It doesn't matter. Somebody came up with this function, it modeled something and said, okay, now what happens? And you said, hey, I'm the man. I can deal with this. But I don't know the antiderivative of sine times e to the power of cosine. So what I am going to do is I'm going to say, well, I know that there is a relationship between cosine and sine when it comes to derivatives. I'm going to go ahead and I'm just going to say, well, let's let u equal cosine of x. And let's see what happens. Well, I now know that du dx is equal to the negative sine of x, which means that the differential du is equal to the negative sine of x dx. And what you might immediately have noticed is that, hey, I've got a sine of x dx in my equation, which means that if I were to put a negative in front of this sine x dx, I would have du. Notice I put a negative out front when I put a negative inside because my two negatives canceled each other out. And now what I have is I have very simply negative integral of e to the u du. And I know this one. This is equal to negative e to the u plus a constant. But wait, there's more. U is equal to cosine. So this is negative e to the cosine x plus a constant. The integral of sine x e to the cosine x dx is equal to negative e to the cosine x dx. Cool. How do you know what to choose for you? How do you know if you can use substitution? Right now, what I'd like you to do is I'd like you to pause and do exercise 19 in the book if you are in my class. And when you come back, we will talk about that. All right, here we go. Here's what I'm looking for. I need u such that the derivative of u is in my integral. There it is. I need to find a function u so that whatever the derivative of u is, it's already in the integral. Let's look at another example where we see this. Example 5. The integral of x squared times the square root of 5 plus 2x cubed dx. I need a u, and I need the derivative of u to be in my function. Well, if I were to choose that as my value of u, the derivative of 5 plus 2x cubed is some multiple of x squared. U is equal to 5 plus 2x cubed. Life just got easier. U is equal to 5 plus 2x cubed. Derivative of u with respect to x is 6x squared. Now notice I don't have a 6x squared in my integral, but I could if I really wanted to. I'm going to put a 6 in front of the x squared. I'm going to put a 1/6 out front. And notice I'm allowed to do that because I can take the constant in and out of the integral as necessary. And now what I see is that du 6x squared dx, if I think about the differential, is here. And this is the square root of u, which means that my integral has now become the very simple integral 1/6 the integral of square root u du, which is 1/6 now integral u to the 3/2 times 2/3. We're using the power plus a constant. And that means that this integral here is equal to, we could simplify. Yeah, sure, why not? Let's simplify. 1/9 5 plus 2x cubed to the 3/2 plus a constant. It can be complicated at first to figure out what value of u should I use. But if you really, really, really think about, hey, I'm looking for something where the derivative is in the integral, it becomes much easier, and it gets much easier with practice. Speaking of practice, go ahead and do exercise 27 in the book. I have no idea whether that 7 just wrote because there's pictures in the way it did not. Exercise 27 out of the book. And we'll be back in the next quick video with some more examples. Thanks for watching.